This is the guided practice for 6.7. I'm going to show you how to do these, and I want you to follow along in your workbook on page 498 and do them as I do them. So we want to simplify each expression. Now, this is all multiplication. So basically what we're doing is we're multiplying 5 times 6 times x. So the way we can simplify that is to actually, the 5 and the 6 can be times together. And so it's 5 times 6 is 30, and then the x, okay? And the way you can see if that works, let's pretend x equals 2. So I'll put it in here. So then it's 2 times 6, that's 12, and 12 times 5 is 60. Now let's put it in here, 2. 2 times 30 is 60. So I get the same answer. So we know it works. And it's just times, times, times. You can always times things together. Let's go over here. Now we don't have multiplication, we have addition here. Now, we actually have multiplication and addition, because this is really 2 times x, 5 times y, 7 times x. And then you're adding these three groups together. Now, I'm looking for like terms. A like term is a variable, a number that has the same variable. So I'm looking at that, and I'm looking at that. 2x and 7x. And if I add those together, it gives me 9x, and then I plus 5y. And that's one way to simplify it, because these are like. Now, we can't say I'm going to add these two together and get 14xy. Because now, this way, looks like we're multiplying x and y together, when we're not. We're just multiplying that x by 9 and that y by 5. Never will these two be multiplied together. They're added. Okay, so you can't, it's not like, you can't add like terms. I mean, you can't add terms that are not like. This is an x term, 9 x's. This is 9 y's. Okay, you can't add them together. Let's look at number 3. This looks like a distributive property one, which we're going to distribute this for. Because it's parentheses, we know that's multiplication. And I can do 4 times 2x. And I get 8x. I can multiply these together because it's 4 times 2 times x. Multiply, you can do it. Doesn't matter if it has an x or not an x. You can multiply it. Then I want to take the 4 all the way over. I got to bring my plus down. And 4 times 5 is 20y. Basically what I'm saying, I want this 4 times this 5y. 5y plus 5y plus 5y plus 5y. 1, 2, 3, 4, 5 y's. And you can add like terms together. This is a y, that's a y, that's a y, that's a y. Add them all together, I get 20y. Okay? But now I have an x term here and a y term here. Not like, so the simplest I can get is 8x plus 20y. That's my answer. Now, we can factor these, just like we were doing in the last lesson. We looked for the smallest number, which is this 28. I'm going to do a factor rainbow for 28. 1, 28, 2, 14, 3, no, 4, no, 5, no, 6, No. 7. Wait a minute. I missed one. 1, no. 1 and 28. 2 and 14. 3, but 4. 4 and 7. How did I miss that one? I didn't realize it till I got to the 7. I thought, oh, 7 goes in there. 5, no, and 6, no. Okay. Now I got to see which is the greatest common factor of both of these numbers. We know these are the factors of 28. So let's look at 35. Does 28 go into 35? No. Does 14? No. Does 7? Yep. Okay, so I'm going to put 7 right here. Now, 7 divided by 35x is going to be 5x's plus 28 divided by 7 is 4, and that's y's, 4 y's. There you go. Now I could distribute that out like this and like this, and if I did it, it would give me this, what we were just working on. Okay? Let's look at 5. Oopsie daisy. We'll do 5 and 6. Michaela bought 5 skirts at X dollars each. So we know we got 5 skirts. I'm trying to do little skirts. Not very good, huh? Okay. 1, 2, 3, 4, 5. There's my 5 skirts. We don't know how much they're going to cost, so we call that X. Of the 5 skirts, 3 of the 5 skirts, so I'm going to go like this, 3 of these 5 skirts came with a matching top for an additional $9. Okay. So this is my top. Not very good either. But these tops, we know they each cost $9. Write and simplify an expression that represents the total cost of our purchase. Okay. So we have 3 of these. 3 times X dollars plus 9 plus 3 of them times $9. Okay. And then we also have 2 that are just X. So we're going to add that plus 2X. Alright, so 3 of them. 3, we buy 3 at X dollars, and then we add, each one has a $9 top, so it's 3 times 9. So that'll give me 27. So it's 3x plus 27 plus 2x, because this is 2 skirts at X price. Now I'm trying to find like terms. I see I have a plus 2 here, and I have a 3x here. If I add those together, I get 5x. So I'll put the 5x here, and then plus the 27. And there's your simple expression. The other way I could have done that is I knew that I was going to get 1, 2, 3, 4, 5 skirts. 5 skirts at X amount of dollars. And then I was going to have to add 3 skirts. 3 times 9. Okay? Because I know I had 3 more that were coming with the 3 tops that were coming with the skirts. And then I would have gone 5x plus 27. Okay? But that's my expression. Okie dokie, let's go on to 6. These are tough. These are tough. The gift bag from Claire Cosmetics includes 5 bottles of nail polish. Okay, so I have a beautiful gift let's see, gift bag. Okay, so this is a nice little gift bag. It has 5 bottles. 1, 2, 3, 4, 5 bottles of nail polish and 2 tubes of lip gloss. So those are my lip gloss. This is my nail polish. Use P to represent the total cost of the nail polish. Okay, so these are going to be P for nail polish, and G to represent the cost of each tube. So this will be G for the tube of lip gloss. Write and simplify an expression that represents the total cost of 8 gift bags. Okay, so I'm going to put one gift bag together that's going to go in here. So one gift bag would be P, 5 bottles times P plus 2 lip glosses, which is 2G. So one bag is 5 polishes and 2 lip glosses. When I times those together, add them, I'll get my total cost. But that's just one bag. It says, what about the total of 8 gift bags? So now I'm going to time this one bag right here, times it by 8. Now I can use the distributive property to simplify this. 8 times 5p is 40p plus 8 times 2g is 16g. So, in simplest form, it's 40p plus 16g. And there's my simple algebraic expression. Okay? So, go ahead and try some of the independent practice, and you can try some, and then I have a video that you can watch. You might want to do some of them, watch the video, try some more, watch a little bit more of the video, keep going back and forth. Some of them are just problems, not too bad. There's some word problems too that are a bit more challenging. So, good luck. Let me know if you have any questions.